All right, so in solving this problem, it says in 1926, Babe Ruth hit a home run that was estimated to have landed 180 meters from home plate and to have reached a height of 21.3 meters. Well, the 180 meters would be for the full trip. That's the displacement in the x direction for the full time. That's the height at the halfway time because he's going to reach its maximum height at the halfway point. So we're going to have to solve a few things to get this. Ultimately, they want the initial velocity of the ball. So we want to get the original velocity of the ball. Now, because I said original velocity and not original speed, I'm going to have to get the magnitude and the direction. So you can see here, based on the picture, that there is going to be an angle, that this thing is launched at an angle. So I've got, there's my x component, there's my y component, and there is an angle. So it's going to be launched into the air. So this is going to represent my my VOX, and this is my VOY. So that's the picture. I only, like I told you, when you launch something at an angle, you should at least have this picture right here because I want to be able to justify when I say VOX is VO times the cosine of theta. Well, this justifies it because it's a right triangle and that's the adjacent side. So now I want to figure out what should I solve first. And looking at this problem and looking at the numbers that I have, I'm going to use my y facts. Usually the y facts are what you use first because most of the time I can get the time from the y facts. So if I list my y facts in this problem, I know that the displacement in the y direction at some point is going to be 21.3 meters. So I know that's at the halfway point, that's the displacement vertically. And I know that it's on the way up, it's slowing down because of gravity. So I'm going to have minus 9.8 meters per second squared. That's my acceleration due to gravity. Now, what's the velocity when it reaches 21 vertically? What's the velocity when it reaches 21.3 meters above the ground? 0, because it stops going up. So VFY is 0 meters per second, and I'm going to use those facts to solve for time. Now, I'm also going to use these facts to solve for VOY. Okay, I'm going to need that also because I need VOX and VOY in order to get this. In fact, the way I'm going to get this is once I know that number and that number, I can use the Pythagorean theorem to get the hypotenuse. And once I know that number and that number, I can use the inverse tangent of that angle to get the angle. Okay, the inverse tangent of that ratio to get the angle. So those are my facts. Step 2 is to pick the correct equation. Now, since we're going to solve for the time first, I'm going to pick the equation that doesn't have the original velocity. So I'm going to use Sy equals VFYT minus 1/2 AY t squared. So that's step 2. And since the final velocity in the y direction is 0, then I can cancel that term out. And if I rearrange this equation to solve for time, and again, I'm not going to go through all the minutiae of the algebra, the time is going to be, so here's the equation. So I'm going to move the minus to the other side. I'm going to move the 1/2 to the other side, which is going to make it 2. And then I'm going to divide by AY. So what I'm going to get on the left side, which I'm putting on the right side here, is minus 2 SY over AY. Now that would equal t squared. If I move this to the other side, that's where the minus 2 SY comes from. Then I'm dividing by AY. That's why it's divided by AY here. That would equal t squared. So I'm taking the square root of that. And that'll get me the time. So I can go to step 4. And the time is going to equal 2 SY over AY. And so for SY, we're going to put in, and the minus. Okay, so don't forget the minus. So it's going to be 21.3 meters and minus 9.8 meters per second squared. And if you solve that, what do you get? It looks like it's going to be somewhere about 2. 2.08. So now that I know the time, now do you have to always keep in the back of your head that that time is the halfway time? So if I need the halfway time, that's what it is. If I need the full time, I have to double that number. So there's my time. I know I'm going to need, I'll stay in the y direction because I do need my VOY. So we'll solve for that now. And I'll use the original facts. I'll do it in a different color. So in fact, I'll do it over here. So I'm trying to save some room. So actually, I already have my facts. So to save even more room, I'm not even going to, the facts are already on the board, but I'm now going to solve for VOY. So in step 2, the equation that I'm going to use is I'm not going to use the time, but I'm going to use VOY is my unknown, VFY, SY, and AY. So the only equation that doesn't have the time, VFY squared equals VOY squared plus 2 AY SY. So that's the equation I'd use. And VFY is 0, so that cancels out. And if I do the algebra to rearrange this to solve for VOY, what I'm going to be doing is moving this to the other side, which would make it negative when I move it to the other side. So it's going to be minus 2 AY SY. Now that would equal VOY squared. So I want the square root so I can get VOY. So that's going to be the square root of minus 2 AY SY. And if we plug in the numbers, we're going to get VOY. Now VOY, whenever you take the square root, it's always plus or minus. But I know if I look at my picture that it's going to be plus because it's up. I mean, you could have it down, right? If Babe Ruth hit a ground ball, then it would be down. The vertical component would be down, but he hit it up into the air. So we plug in the numbers, and we get minus 2 AY SY. So for AY, we put in minus 9.8 meters per second squared. And for SY, we put in, what, 21.3? And so if we solve that, that's going to get us half of our VO, because it's going to get us the Y component of our VO. And what does that work out to be? It looks like it's going to be somewhere around 20. Whoops, 20.4 meters per second. Everyone still with me? So now we want to get the VOX. I'll pick a different color here. So now we want to write down our X facts. Yes. We solve for time not because we need it at this. I mean, we haven't needed it up till now. But in order for me to get VOX, when I write down my facts of VOX, you're going to see I'm short one fact, and it's going to be the time. So since I had to solve for the time at some point, I just solved it right away. Yes. No, because we need the angle. If I knew VO and the angle, then yes, I could use those two to get the other. I could get a component, but I don't know the angle yet either. So that's the problem. If they actually told me the angle, then you're right. I could have. Once I know that, I could actually use the angle. I could use the angle and this number to get the VOX or the VO. So actually, you know, it's interesting that you say that because I can what you just said, and I've always solved now for the VOX. But what I could do as an alternative to even using the X is, no, I still need my VOY. I was thinking that somehow I could get the angle, and then I could use the angle with my VOY, but I need both. I need two components to get that. Yes.
Can you use like the VF equals VO plus AT?
for the VOY, VF equals VO plus AT. Let's see. VF equals VO plus, to get, yes, you could do it. The reason why I didn't, you could do that. The reason why I didn't do it is usually by practice, my default is not to use a fact that I calculated, to use my original facts that were given in the problem. That way, if I made a mistake on part A, I won't make a mistake, it won't affect my result for part B. But you could have used that one if you think that that's an easier. In fact, some people might use it because they just like that formula you just said better than this one. Yeah. The algebra is tougher here than it is with VFY equals VOY plus AT. Yeah. So now we're doing if we write down our x facts, we're going to have, we know SX. So we know it's 180 meters. That's how far the ball travels horizontally. But that's the full trick. So what should I write down for the time? Right, I should write 4.16 seconds because I need this time to match that distance. Now, another thing I could have done if I wanted to use 2.08 is I would have used 90 meters. Because I know that if it's going to go 180 at the halfway point, it will be 90. And I could use 90 and 2.08, and I'm still going to get the same answer. So it depends. Just make sure they match. Make sure your time matches your distance. And then we have that the acceleration in the x direction is what? 0. And so I'm solving for VOX. So if those are my facts, my equation is going to be SX equals VOXT plus 1/2 AX T squared. And what's great about this is AX is 0, so 1/2 AX T squared is 0. And if I solve for VOX, so step 3, I'm going to get VOX is going to equal SX divided by T. And so my SX is 180 meters. And my T is 4.16 seconds. And what does that work out to be? It was like 43.3. All right, so 43.3 meters per second to 3 significant digits. And now that I know both my VOX and VOI, I'm running out of time here on this video. So once I know both VOX and VOI, then I can use a squared plus b squared equals c squared. So c, which is the hypotenuse, will equal the square root of that number squared plus that number squared. That will get you that value. And at the angle, I know that and that. So opposite and adjacent, I would use to get the angle, I'm going to use the inverse tangent of that ratio to get that. All right, I'm going to shut it off here so that if I go beyond 15 minutes, it's going to